Hi, so in this video we're going to be going over what formal charge is, how to find it, and how we use it. Let's start. Basically, formal charge is the charge on a single atom in a molecule. So the way we calculate this, there's one main equation, and that is the valence electrons subtracted by the number of non-bonding valence electrons minus the number of bonding electrons divided by 2. So what we're going to do is we're going to look at this Lewis dot structure of carbon dioxide, and we're going to figure out the formal charge of each of the atoms in it. So let's take a look at this oxygen right here on the left. So the number of valence electrons of oxygen is 6, as it is in group 6 on the periodic table, and the number of non-bonding electrons is 4, because we have 4 aka 2 lone pairs, and that gives us 2, and then 2 minus the number of bonding electrons. Well, it has 4 bonding electrons divided by 2, which is 2, and that gives that oxygen a formal charge of 0. So now let's do this with the carbon. So the carbon is in group 4 on the periodic table, so it's got 4 valence. It has 0 non-bonding electrons, and it has 8 bonding electrons over 2, which is 4, giving the carbon an overall formal charge of 0. And 0 is a very ideal formal charge. We'll get more into that in just a minute. But before we move on, we want to find this formal charge of the last oxygen, in which I can show you another way to find the formal charge. So we can see these bonds as 2 separate electrons, right? So there's 4 electrons, only 2 are really attached to this oxygen though. So we know that oxygen has 6 valence. And to quickly finish up the formal charge, you just have to look at how many electrons are directly bonded to the oxygen. So in terms of all the electrons that are actually next to the oxygen, there's only 6. So you would do 6 minus 6 equals 0. And that's just another way to find the formal charge. You can always use either method depending on which you like more. Okay, so now we're going to get into why exactly we use formal charge and why it's important. So Lewis dot structures can have different versions of themselves, aka resonance structures. And even though they are all valid in their own way, there's always going to be one structure that's more valid than all the others. And that's kind of where formal charge comes into play. So we have an example right here on the right of tricyanate. It's an anion, and we're going to look at these 3 structures and figure out which is the best. The first thing you always have to consider when determining which resonance structure is the best is the octets. We have our exceptions of hydrogen and boron, but if the atom needs at least 8 electrons, you have to make sure that is satisfied. We have to make sure the octets are full. And looking at each of these structures, they do each have full octets. That is all good. So now we have to consider next is the formal charges of them. So we already have our formal charges all figured out. Now let's actually use them. We see the top structure has 0, 0, minus 1. The middle one has a minus 1, 0, 0. And the bottom one has a minus 2, 0, plus 1. And ideally, we want the formal charges to have as many atoms as we possibly can to have no formal charge, or we want it to be relatively low. So just looking at this, the bottom one we're going to knock out because it only has 1 atom in it with no formal charge, whereas all the others have 2 atoms in them with no formal charge. And also it does have a minus 2 formal charge on the nitrogen, which is really not ideal. That's a little low. We want to stay in the 1s and the 0s. So now we have these 2 left that we need to determine which is better. And how we're going to find out that is by looking at the electronegativity of each of the atoms. So though nitrogen and sulfur are a little close together on the periodic table in terms of their electronegativity, nitrogen actually has a electronegativity of 3.04, whereas sulfur has an electronegativity of 2.58. So that means that the nitrogen just barely beats the sulfur. in terms of its electronegativity. And the reason why this is important is because we want the negative formal charges to be on the more electronegative atoms. So let's take a look at our structures. So the top one has a 0 formal charge on the nitrogen. It is a 0 formal charge on the carbon and a +1 on the sulfur, or a -1 on the sulfur. And then we have a -1 on the nitrogen on the middle one with no formal charge on the carbon or sulfur. And that leaves this middle structure to be the most ideal. This because it checks all the boxes. It has full octets, it has the most atoms with no formal charge, and it has the more negative formal charge on the most electronegative atom. And those are the 3 things that will lead you to figuring out which resonance structure is the best. I hope that cleared some things up for you. Thank you for watching.